Yo, what's going on, guys? Today we are hopping into Wireshark. One thing you guys will notice is I obviously moved my camera. I'm not sure that I love it yet, but we'll see. I'm trying to keep it out of the way, but also I think it's important to interact with you guys a little bit. I'm not a big fan of the just videotape the screen and kind of talk, but we'll see what happens. So anyway, this is a continuation of our cyber defense, guys. So we're still diving into cyber defense. We're going right down that path and we're moving right along. If you guys are enjoying the cyber defense path and enjoying this content, please subscribe and like the videos. It helps so much. Comment below. Let me know what your guys' favorite box is, what your guys' favorite challenges are in cybersecurity in general. So without further ado, let's hop into it. First things first, it just tells you that you should have the introductory networking, which we've done, so we don't need to worry about that. So let's go ahead and complete and move down. Okay, so now it's going to tell you about installing Wireshark. If you guys have never heard of Wireshark, that's all right. This box will kind of walk you through it. But to install it, it can run on Windows, Mac, Linux, and I will tell you, in every position I've ever been in cybersecurity and in IT, really, I've used Wireshark in some facet, even as like a sysad years and years ago, whatever. I remember messing with it even before that when I was just barely learning IT. I was using Wireshark for capture analysis. So Wireshark is a tool that you really want to be familiar with. I'm not saying be an expert in, but you need to know how to at least navigate around in it. All right, so that'll tell you how to go ahead and install it if you want. All right, so Wireshark overview. So let's go ahead and open it up so that we can see what it looks like as well. So this is what it looks like here. They're going to walk you through some stuff, but I'm going to kind of just walk you through it as well with this over here. So these are screenshots, and you can see it says enter a capture filter, all interfaces shown. So this would be, and you can see these are all the interfaces. This would be capturing packets from all interfaces, meaning from every, so like for instance, this is ETH0. This is the Ethernet interface on their, the attack box. And that's the IP address for the attack box. So it's going to capture all of this. So anything that comes in and out of this box or on this network is going to get captured. So you can see here, there's all the stuff that we've opened in the past. So that's going to be your history, which was from this box. And then you can see here, if we begin navigating to the green ribbon in Wireshark, which is that, you can see it allows you to add filters. So if you guys don't understand what filters are, it's very similar to, if you guys are familiar with SIEMs or SIEMs, security information and event managers. If you guys are familiar with these, the filtering is going to be very similar on a lot of SIEMs than it is on Wireshark. Now, that's not true across the board. It's just in my experience, a lot of SIEMs use very similar filters. So, and it's just computer filters. It's Boolean factors and things like that, which sounds complex, but it's not. So for instance, if I wanted to say IP.source, so if I want the source IP address for the packet to equal, you put two equals to equal, and we'll say 1.1.1.1.1, right? Now, granted, that's not going to do anything, because that's not an actual source, but that's how it works. So Wireshark has a nice feature too. If it's a legitimate filter, it turns green. Otherwise, it won't let you search for it. So you know if you type something wrong or something like that. So we're gonna be working with some filters today. So here we go. From the screen, Wireshark gives us important information about each packet. So, excuse me. This is a sample capture. We're going to go through packet capture, so I'm not going to pull up a sample packet because here you go. This is what it looks like. You can see the sequence there. You're going to see the time, the source, the destination, and what protocol it's using, how big it is, and the information. Now, the information we'll cover here when we cover HTTPS, but the information only goes off if it can detect it. So keep that in mind, that you can't just look at it and say, oh, it says SSL, so it's nothing. Because it might have actual information you need in there, but it might be encrypted or something. Okay, so this screen is where you do most of your analysis and dissection of packets. To open a packet, you open, select, So you would just go to File, Open, and Select. Now, the way I'm going to show you guys the other way, this is the way that I do it. It doesn't really matter how you do it. So yeah, this is at quick glance, along with some quick pack information. Wireshark also color codes packets in order of danger level, as well as protocol to be able to quickly spot anomalies. So that's important. Not only is it by danger level, but it's also going to be good to color code them, because that way we know when things are changing. So for instance, when you can see on this one, you can see like here it's an ARP request, and then all of a sudden it's a TCP flag reset request. Okay, so we know, even if we didn't know that red equals bad or whatever, we know that it's changing just at a quick glance. We know that the protocol is changing or that something is different, right? Okay, so read above and play around with it. So that's going to be kind of the theme, is you need to play around with it. All right, so here don't worry, I've got notes for all this stuff, guys. But Patreon members, this will be available for you guys. You guys have the link in the Patreon for all the notes that I do. And it'll be a lot more detailed, but here we go. So one thing to keep in mind when you're doing Wireshark is there's different reasons for Wireshark. So number one, troubleshooting. A lot of people use Wireshark for troubleshooting. If you're a network administrator or something like that, you might troubleshoot an issue or try to replicate an issue and then just see what's going on with the packets. Another reason hackers use it a lot is for network taps. So one of the things they're doing here, this is a physical tap, meaning it's actually going to go around the copper cable and it's going to puncture it, and it's going to get the messages off of that hard line. So that's a hard line tap. Now, this is a very famous tap. You can buy them. They're real cheap. You can make them. They're real cheap. But this is a throwing star tap. Now, you can see the reason it's named that. But basically, you plug in one thing here, plug in whatever device you want it to listen to. So a lot of people use like a Raspberry Pi and send the information out, and you plug that in here, and it takes whatever information that you tell it or that you plug in the network, and it sends it on to its regular destination just like it's supposed to. So it comes in and it sends it off just like it's supposed to, so nobody knows it's there, but it's also replicating those packets and sending them off to you. So it's just a way of basically you plug in your target machine, and then you plug in, whether it's a Raspberry Pi or whatever on the side, whatever you want to plug it in. And then here, you would just plug in the other side going to the switch or router or whatever. Now, a lot of people always ask me like, yeah, that's great if you're there, right? Because people think of hackers, they think they just sit behind a keyboard. Well, you got to understand how easy it is to get something like this on a machine. When I say that, let's say you work for a company, or you go to do a pen test for a company, right? And you just do quick Google search, quick research, and find out that their internet service provider is AT&T, for instance, right? Well, how hard is it to get an AT&T shirt and a fake badge, right? Wear a badge, it's got your picture, it says AT&T, you got an AT&T shirt, you show up, hey, I'm here because we did some updates on our switches, and we're basically your internet has been intermittent probably, and we just want to make sure that everything's all right. You could make up a very quick story, very easy, 10 minutes worth of work, and they're going to let you right into their IT into their IT room, most likely. And when you walk in there, go ahead, unplug it, act like you're plugging it into a tester or something, watch the numbers. As soon as they look away, you plug that throwing star in, boom, boom, say, you guys are good, thanks, see you later. And you're now intercepting the packets. That's 10,000 times easier than it would be to actually sit there and try and break their firewalls, break all that stuff. So keep that in mind. All right. So I kind of went on a tangent there, but MAC floods. So MAC floods are tactic commonly used by red teams. This is a way of sniffing packets. So what is a MAC flood? So MAC flood, basically they're sending your MAC table or your CAM table, they're sending them MAC addresses, but the MAC addresses aren't real, right? So they're invalid. So what this is, the MAC table is on a switch, is basically keeping all the MAC addresses for every port. Well, if you fill that CAM table, you just keep overloading it with invalid entries. Well, once it hits that cap, let's say the cap's 100, let's just say. Once it hits that cap of addresses it can keep, it doesn't know what to do anymore because it's not sure which port has what. It doesn't know what's going on. And so it will start sending packets on all ports, okay? So that's big because now even if you have a computer that you took over that has no access or whatever, well, all the information on the network is now coming to that computer. So you can start using Wireshark to capture it all. All right. So now ARP poisoning. This is another tactic now keep in mind, guys, Mac floods, it says right here, this technique should be used with extreme caution with explicit prior consent. 100%, that is something you need to take into serious consideration. Not because you might get caught, not because it's illegal, because all that's true, but it is going to cause issues. It might cause issues. It will cause issues, 100%. Even if it's just slowing down the network, you're going to have some problems. So keep that in mind. So when you're doing this, even if you're doing it on a pen test, 1000%, it should be in writing that is an authorized procedure that you can do, because businesses are going to complain big time. All right, so ARP poisoning, another technique. This one's a little bit more tactical, a little bit more finesse, if you will. So ARP poisoning, redirect traffic from the host, the machine you're monitoring. So if you guys aren't familiar with ARP is address resolution protocol. So it assigns an IP address to a MAC address, basically, right? So when that happens, what you can do, so ARP was designed for efficiency, not for security. So what that means is you can tell an ARP table, hey, I'm so-and-so. And the ARP table says, okay, cool. And then when they get a request for so-and-so, they send you the request. Well, now you tell, the target, hey, I'm actually the router. Well, the target, again, it's just updating the ARP table. Okay, cool. So when it sends something, it's going to send it to you. Now, the key here is you have to have something, so you're in the middle, you have to have something that forwards the packets on as if you're not even there. So what happens? You have a target sends a packet to the router, but you are pretending to be the router, so it comes to you. You analyze it and send it directly on to the router and say that you're the person that sent it, and the router thinks, okay, cool. So the router sends it on to the website or whatever, just as if normal, and then when the request comes back in, the router sends it to you thinking that you're the one that made the request, and you send it right back to the target, and then they're not the wiser. They don't realize that there's someone in the middle of them forwarding their packets, and you're actually capturing all their data. All right, so there's some of the things. Now, let's go ahead and start looking at filters. So here is where you're going to have to be a little bit familiar with Boolean filters, which isn't a big deal. Boolean and logic operators is pretty simple. It sounds crazy, but it's not. So for instance, for an AND operator, so if you want to say the IP address is 1111 and the MAC address, and the MAC address is so-and-so, you would put two AND signs. If you want an OR operator, you'd put two pipes. So OR would be if the IP address is 1111 or the IP address is 1112, right? That would be OR. Now equals, we already saw that one. That's two equal signs. Not equal, pretty self-explanatory. Greater than and less than. All right. So the greater than, less than, obvious. Equal sign is two equal signs, obvious. And the bang and equal sign is the other, right? All right. So basic filtering, you can see here IP.address equals IP address, and that'll give you your basic filter. The source IP.source, that's just going to give you the source IP address, and then IP.dest is destination address. So that's pretty self-explanatory, pretty easy. I'm not going to get too crazy into that, so that way you guys don't have to hear me on a rant. Let's see. So now you can filter by UDP port. So that's really good because you can filter by TCP or a UDP, but you can filter by the port. So TCP.port equals, and then the port number. So now, or the protocol name. So now now you're set, and you know exactly what port you're actually watching. So keep that in mind when you guys are doing these type of packet inspections, that you're gonna, because it sounds like the filter is complex, but it's really not. And then once you get into actual packet inspection, you're going to be looking at thousands, if not hundreds of thousands of packets, if not millions. So you need to know how to filter out what you don't want. Okay, so packet details. This is how a packet's going to come in. So you can see it has up to 7 different layers here that it can actually present you with. So you can see 1, 2, 3, 4, 5, 6, 7, right? Now, not all packets are going to have this. Keep that in mind because not all packets are going to provide that much information. Not all packets need all of this, but this is how it can be broken down. So you can see at the frame level, that's telling you, okay, it's Ethernet. So we're looking at the physical layer on the OSI model. The MAC layer or the MAC address is on layer 2, so that's telling you right there. We're looking at the data link, and you can follow this up here if you want. So you can see, okay, the data link's got the Ethernet and the frames, so that's there. So the physical is actually, I don't know why I said it the way I did. The physical is actually like the physical pieces, like the wire, the RJ45, like the actual connectors and stuff. So the data link is going to show the actual frames, and that's why it's named frame. Now you're going to see it tells you, if you are familiar with the OSI model as well, it'll tell you what like protocols and stuff. So you have Ethernet. Let's see, not scrolling. There we go. So then you have network will be packets. So the packets will be IP, ICMP. So basically what you're doing. So then you can see here, layer 3, it gives you that layer 3 right here. That's layer 3 network. And that's going to start showing the IP addresses, right? So layer 2, the data link network or data link address is showing the MAC address. The physical or the layer 3, the network is showing the IP address. And then layer 4 is going to start showing what protocols. So you can see here, layer 4, the transport layer, TCP, UDP. That's what protocols are actually in place. The protocol errors. So this is may not be on all of them, maybe on some of them. It's going to show you what error or what packets had to be reassembled, any issues with them, what errors you get. That's it. Okay, then layer 5, you're going to see the application layer, and you're going to start seeing, okay, what application am I using? What am I doing? And that's HTTP, for instance. That's an application that it's going to start looking to use. And then application data is an extension. So you can see it's broken down similar to the OSI model, but you're going to notice when we start doing the packet inspection, you're not going to have those exact, every single packet's not going to have those. All right, so luckily we don't have to download all those. Those are on here. So let's go ahead and look at ARP or address protocol in layer 2. So this is task 7. So let's go ahead and Wireshark. So this is the way I open them. Just type Wireshark, super easy. Task 7, and it'll open it right up. Okay. So now, so it's telling us right here, ARP or address resolution protocol is a layer 2 protocol that is used to connect IP addresses with MAC addresses, which we covered. They will contain a request and a response. So to identify the packets, the message header will contain one of the 2 operations, request or reply. So that's good to know because we can actually filter and search for a request or a reply if we want to. So it's useful to note that most devices will identify themselves or Wireshark will identify it. So what they're saying is if Wireshark doesn't identify it, you can see here, it identifies itself, but Wireshark can probably identify it based on its MAC address and things like that. Okay, so looking at the below screenshot, we can see that the Cisco device is sending ARP requests. So this is not what we're looking at over here. This is different. So the Cisco device would probably be your switch. So that means you probably should trust it that it's sending out ARP broadcasts. Now, this, you notice that we don't have a Cisco device. We have a Hawaii device. Huawei, whatever it is. I used it overseas, but I don't know what it is. Okay. We can begin, I don't know what its name is, but we can begin analyzing packets by looking at the first ARP request packet and looking at the packet details. Okay, so let's look at the first packet. And is this the same one? This is not the same one. Okay, so they're looking at a different one. So let's go ahead and start answering some questions. So now that you know, now that you know what ARP packets and normal traffic look like, which we do, let's dive into an exercise. So we started the box. What is the op code for packet 6? So you can see we have the number scheme here. So let's go to packet 6. And then we can see here we've got only 3 things here. So we have frames, which is not really what we want because we don't need the physical. But there's the op code under ARP, op code, request 1. So what is the opcode for packet 6? Request 1. So they're trying to get you to be familiar with where to find this information. It's not necessarily vital that you understand ARP completely inside and out to do this. It's just understanding where it's located in the files. Okay, so what is the source MAC address of packet 19? Okay, so let's go to packet 19. Okay, and the source MAC address. So the sender, MAC address, because that's the source. That's where it's coming from. There you go. Pretty easy, guys. So what 4 packets are reply packets? So this one's actually a little bit more interesting because you have to actually start using filters to find the replies, but it's just do a little bit of research and you can find it. And I'll show you guys the filter here. I've got so many notes here. Okay, so all we got to do is type the eth.address, which is Ethernet address. And you can see it saved my filter from before, so that's the same MAC address. And when we hit enter, oh wait, that was what we used for the last one. I'm sorry, I skipped a question. So there's the IP address. What IP address is at this MAC address? Well, there you go. I just skipped a question and told you. So if we hit enter there, you can see right there should be, let's see. Ethernet address is this. So if we go here, and then the IP address is 10.251. Oh, that's not right. All right, hold on. Let's go back to the other question. I skipped a question real quick, and then I got myself confused. Okay, so where are we at? Okay, here we go. That's why. So to do this, we just have to do the ARP code. So the arp.code, and you can see arp.opcode equals 2. So if you remember the opcode, so you just specify ARP, address resolution protocol, .opcode, and then we don't want 1 because 1 is the, you can see here, they say it up here, they show it to you. Yeah, so right here, the 1 is the request we're looking for. They're specifically asking for what 4 packets are reply. So we want 2 because we want the reply. And then here you go. So you need packet number 76, packet number 400, packet number 459, and then packet number 520. Now, here's the funny thing about this question, which is what is the IP address at 80FB06, whatever MAC address, is right here. All 4 of these replies are from 80FB06. So there it says 10.251.231 is at that MAC address. So it literally gives you the answer for both those questions. And that's why I was confused because I skipped a question. Okay, so we're done with that one. Let's go ahead and task 8. And you can see that it's a different type of file, but it's still a pcap file, so don't worry, it'll still work. Okay, so let's go ahead. ICMP traffic. So we've covered ICMP before on this channel, so if you guys, I'm not going to dive too deep into it because we have covered it before. But if you guys are curious, it gives you some resources, a little bit of information. Right here's the documentation. You can go through and really read it if you're curious how ICMP works. But ICMP is used for things like ping, traceroute, that type of stuff. So it tells you like right here, type 8 echo ping. Okay, so you can read it a little bit. This is the request. This is the reply. And you can see you get different types depending on what you're doing. So now we go to packet 4. It's asking us what is the type for packet 4. So we go to we go to packet 4 and we go to the ICMP, Internet Control Message Protocol. So you notice if you know ICMP, you can just go to that part of it. And you can see here it's type 8, echo ping request. So what is the type for packet 4? Type 8. And what's the type for packet 5? Just go to 5, same thing, ICMP, type 0. All right, so what is the timestamp for packet 12? So this is a little bit more realistic. This is more what you're going to do in real life. So packet 12, they said, right? Only including month, day, and year. Okay, so don't have to include the actual time. Note, Wireshark bases its time off your device's time zone. If your answer is wrong, try 1 day more or less. So that's important to note, because if it is wrong, it just needs to be moved a little bit. Okay, and that's only because it's basing it off your time. So therefore, if let's say you live in New Zealand and you're a day ahead of me, you may have a different time on here. Okay, so here's our timestamp right there, May 30th, 2013. So that's pretty easy. All right, so now what is the full data string for packet 18? So this is where you would start looking for actual data. So here's our data under the IC, and there's the data string. So that's it. That's all they're looking for. They want that data string, okay? And the reason they're looking for the full data string is just to see that you know where it's at and how to get it. The ICMP itself doesn't have a lot of data in it because this is a ping, so it's just sending you something to see if it gets a reply. That's it. But if you actually were sending like a message or something, you would get an actual response, and it would actually look like real data. Okay. All right, so now we're on task 9. So that's the end. Let's see if we have a task 9 pcap. Doesn't look like we have a task 9 pcap. It looks like the task 10 is the next one. So before we get into it, guys, I want to go ahead and introduce you to Manscaped, today's sponsor, and I really appreciate them. I actually am pretty excited. So they sent me some stuff. I use you guys know already that I use the weed whacker or the lawn trimmer, whatever they call it, the trimmer 4.0. And then, I've got the bag. I use the ball deodorant. I actually love that stuff. And then the trimmer, it speaks for itself, guys. There's a reason a lot of people are sponsored by them and actually use the sponsor because it's incredible how different it is to other trimmers. It's made specifically for, your necessary private parts. I will tell you this thing, though, I am using this tonight. So I'm going to try it out. I never thought I'd reach an age where I need a nose hair and ear trimmer and all that stuff, but I am interested to tell you guys how that works because I was so impressed with the actual trimmer. So hopefully you guys buy yourself one, but also hopefully you guys enjoy it if you do have one. If you do, you can use code Stuffy24 at manscaped.com. And if you use code Stuffy24, not only do you get 20% off, but you get the free shipping. So that's a huge deal because especially if you buy the deluxe package, which is what I have, and that has the bag, the boxers, the ball deodorant, the lawnmower, the weed whacker, all these things. And if you do, that shipping is probably going to get pretty expensive with, how big of a package that will come in. But I didn't have to pay for that, and neither will you if you use the code Stuffy24. So go ahead and use that code at checkout, guys, and let's get back into task 9. All right, so TCP protocol, transmission control protocol. So this is what you're familiar with. This is a TCP protocol. You guys are familiar with it and UDP, or should be. If not, you can read up on it here. But the big thing they want you to know is that there's a TCP handshake, because that's what you're going to look for when you're starting a connection, especially when you start getting into some of the HTTP and stuff like that, or any sort of connection-oriented protocols. So here we go. For analyzing TCP packets, we'll not go into detail. However, look at a few behaviors and structures. So basically what they want you to do is they want you to know a little bit about TCP and understand how it works. So you guys can read through this if you want to understand how it works, but you can see they're showing you the format. So the source port, the destination port, sequence number, acknowledgement number, that type of thing. Because in TCP connection oriented, it's going to be sent in sequence. It's going to be sent 1, 2, 3, 4, etc. So you can see here you can turn off relative sequence number, so it gives you the actual raw sequence number, because relative is the way it's put back together versus the actual way it came in. So that way you can see if something got messed up or whatever. All right, so there's nothing they need us to see there. Now, DNS traffic. So this is where you're going to actually start diving into some DNS traffic, which is quite interesting. So we want task 10. Okay, so you can see here there's a couple things outlined you should keep in mind when you're analyzing DNS packets. So query response, okay, DNS servers only, and then UDP. So UDP is the alternative to TCP. It's connection list, so keep that in mind. Looking at the below query, we have 2 bits of information that we can use to analyze packets. So UDP 53, which means this packet passes that check. So basically what they're saying is this is destination port, but it's using UDP. So if it was TCP, then it would be considered suspicious. My dog's freaking cracking me up. But if the reason is because we know it's 53 is DNS and we know it should be using it. But if it was TCP, it means it's connecting. It's actually having a session, which is weird. We would know that's kind of messed up. That's where a SIEM would come in and notice that right away, because you might have thousands of machines running that you're needing to analyze at once. And then you could open it with the pcap file with Wireshark and start diving into exactly what happened. Okay, so practical DNS packet analysis. So this is where you're going to start seeing real life because these are real packet captures. Jordy, stop. These are real packet captures. So what is being queried in packet 1? So packet 1, here's the actual query. It even says query on there for you. All right, queries. Okay, and there it is. It's 8888 in address ARPA. So 8888 is Google's DNS server. So it's actually querying Google's DNS server right off the bat. What site is being queried in packet 26? So if we go to 26, so keep in mind this is all DNS traffic. So if we go to queries, it's wireshark.org. So you can see they're actually querying wireshark.org. Now, what is the transaction ID for packet 26? So this is the actual packet right here. And then here's the actual transaction ID. So this is just showing you guys how to find some stuff in the DNS if you're looking for an actual DNS inspection versus if you're looking for, some underlying protocol or something like that. All right. Now, we're in the HTTP traffic overview. Now, if you don't know how HTTP works, it's pretty simple, but we're not going to dive too deep into it. You can go here and read more about it as well. But HTTP, we're going to kind of try and fly by because HTTP isn't really in use anymore, so it's pointless. Now, is it still in use? Yeah, a little bit, but you know what I mean. So let's go ahead and open up task 11. All right, as that's opening, after opening pcap, we can see this is just a simple HTTP packet with a few requests. So see how we can scroll down here and you see just a handful of requests. What is it, 43? So 43 packets. This will most likely never happen. Usually you're looking at thousands. So you've really got to understand how to navigate around here. And that's why they're telling you or showing you this, because yes, these are small packets, but you can still go through a larger file and do the exact same thing. Okay, so now navigating deeper into the packet capture, we can look at the details of the HTTP request. For example, packet 4. So let's see, is this the same packet that we're on? It is. Okay, cool. So from this packet, we'll go ahead and do this. So you can see they went to ethereal.com and there's the /r/n. They used Mozilla Firefox on a Windows machine. So you can start seeing how you can start getting some information pretty quick, even if they don't have like the actual network tap hooked up, which if you have a network tap, like you're pretty much going to see everything. But I'm saying even if they're somehow encrypted and you're just getting this information from the HTTP initiation or something, like that's pretty big information. So you can see here the refer. So it was actually referred by the development.html file. So that's interesting because that means it's getting the download from HTML at ethereal.com, but it was referred by development.html, which means that was where they were before and it referred them. So you're starting to see, you can start seeing the pattern of what they were doing. You can see here that we can use some of Wireshark's built-in features, and we're going to do that down below, so I'm not going to cover that. All right, so first thing, what % of packets originate from the DNS system? And that's exactly what they're saying right here. So you go to statistics, and you go to protocol hierarchy, and you can see right here, UDP DNS, 4.7% of the packets are DNS packets. So there's 4.7%, and they just want you to see it and understand it. So, or how to see those. So what endpoint ends in 237? So here we go. So now we got to start actually looking at it. So the first thing we have to do is find what endpoint ends in 237. So there's a couple different ways you could do this. You could do a filter, right? But if you look, the second packet, pretty much, all these packets have that IP address that ends in 237. So it's pretty simple. 145.254.160.237. Now, if you know the IP address, you could filter for the IP address. And then when you filter for it, it's just going to only show those. But we didn't even have to do that. So now, what user list agent packet 4? What user agent is listed? Jesus. Okay, so if you guys have ever messed with Burp Suite, you've seen HTTP and HTTPS packets, and you know the user agent is what they're using their, not their operating system, part of it's their operating system, but their web browser. So you can see they're using Mozilla 5.0. Boom, boom, boom. There you go. So now looking at the data stream, what is the full request URI for packet 18? Let's go ahead and dive into 18. So 18, you can see, here we go. And then it says, what is the full requested URI? Here's the full requested one. Page add to.googlesyndication.com. Boom, boom, boom. So you guys can see that you can actually see exactly what they're requesting. And then you can see that they'll make it truncated for you. You see the refer. You can see all kinds of stuff. The actual get requests that they made. So now, what domain name was requested from packet 38? Now, if you go to 38, you can see here the actual domain name is just right here. So it actually is, that's the full requested URI, but the domain name is just ethereal.com. So there's www.ethereal.com. And then it says, looking at the data stream, was the full request URI from packet 38. So the same thing, but they want the full thing now. So hopefully you guys are starting to see how to look for stuff in here. I mean, if you know you're looking for HTTP traffic, then all you got to do is go to the HTTP dropdown and find what packet is doing what you want it to do, and you use filters to find it. And there you go. You're pretty much on the right path. Now, HTTPS, this is a whole different ball game, and I'll show you this will show you, why we use HTTPS nowadays versus why we use or don't use HTTP anymore. So you saw HTTP, we could just sit there and monitor and do everything, and everything's all hunky-dory. Now, the RSA snake oil, so I unzipped task 12. It's the RSA snake oil. I'm not sure why they use that. So we'll say RSA snake oil 2.cap. Okay, so we opened it up, and here's the big difference. You can go through here and read all this and do everything if you want. If you don't know how HTTPS works, HTTPS establishes a key with the target. So when you go to a website, it establishes a key that you guys exchange when you guys using your public key and private key. That's a little bit beyond the scope of this. But once the key is exchanged, from there, you guys have an encrypted channel, and you guys exchange information. Now, when you're exchanging information, you can see this is our exchange. You can see a lot of it says SSL version 3, SSL version 3, right? And if I follow it, it's all encrypted. Nothing really makes sense. We're not going to find much, right? So the big thing here is that SSL version 3. So we need to get it unencrypted. Well, in order to do that, we have to have the key. So that's why you notice why we use HTTPS, because we need that key. Now keep in mind, that sounds to you like, oh, everything's secure. If you did something illegal or something like that, the government can very easily get a warrant to get that key, that exchange key. Okay, so keep that stuff in mind. But what we need to do, let's pretend we're doing an investigation and we have that key, okay? So what we need to do is we need to go to Edit, Preferences. And now, because HTTPS, we're using SSL. Now, yes, I get it. Today we're using TLS, but this doesn't have TLS on it. I'm not sure why they don't have TLS on this, but whatever. It's kind of weird, actually, because they mention it right here. They mention it somewhere that If you're using an older version of Wireshark, then this will be SSL instead of TLS, but this is their version of Wireshark. So it's kind of interesting that they did that. They even said that, but whatever. So you go to SSL. You have to edit the RSA keys list, meaning you got to put the key in there. So we'll click the add button to add one. Okay, guys, welcome back. For some reason, the attack box just crashed on me, and I have no idea what happened. So you go here, and you go to create new entry, and then from here, it tells you exactly what you need to put in here. You just put the local IP. Then the port, you're just going to put start TLS. So TLS is replacement for SSL, so it's the same thing. Don't worry about that. Then you want HTTP, and then the key file you're going to put, they give you the key file. So keep in mind, this would be if you're doing like some sort of forensic investigation or something, you would get this key. Now when we do this, you're going to hit OK, OK. And you notice all of a sudden these SSLs, some of them, a lot of them, turn to HTTP. So what's that tell us? It tells us that now it's not encrypted anymore. Okay, so now looking at the data stream was the full request for packet 31. So now that we decrypted it, basically, we're going to go here. Whoops. We're going to go here, look at the data stream. So we can go to the HTTP data stream. And you can see the full request is right here. Localhost, icons, Apache. Boom. Perfect. That's perfect. Now you can see that we put the IP address in as local. It doesn't matter what you put it in, if you know the IP, if you don't, whatever. So now looking at the data stream, what is the full request for packet 50? 50. Okay. And the full request is local host icons back.gif. Okay. And then what is the user agent? The user agent is Mozilla right there using Linux. Interesting. Now, let me show you guys something kind of interesting here. This is just something I want to show you. You don't have to, this isn't part of the box. But what you can do that's really nice is you can follow the HTTP stream. You can follow any stream. And you notice it is not encrypted anymore. So you can see exactly what's going on. So you can follow it. You can say, okay, they're getting a request to the website. Cool. And then they get the okay, so they get the response. And then here's the website. So I could theoretically copy this and render the website if I wanted to. But it says here, the initial installation of Debian Apache SSL. If you're just browsing the web, the owner of this website has not put up any web pages yet. Please come back later. So this is a default web page that doesn't exist currently. There's nothing there. And then you can see the href, which is just a anchor reference. Is apache.org. So this is just a blank Apache website. So kind of interesting that you can actually really, if you want to, break everything down to a T of what someone's doing. All right, so let's go ahead and go to the last step here so we can terminate this machine. All right, so zero login pcap overview. So I'm not going to cover this too much, mainly because the whole point of task 13 is for you guys to mess around in it and to find what they're talking about. So it would kind of be pointless for me to walk you through it because that's the entire point. There's no questions on it. You're not going to miss anything. But what it is they're trying to show you this is an actual vulnerability. And this isn't secret stump is an actual attack that happens. And with that, they're going to give you information about it, and they want you to dive into it and kind of see if you can see the step-by-step with having a little information about what it does. And they tell you what it does and how it acts. So you should be able to find it pretty easily. It's nothing crazy. It's not that hard. And they kind of show you even where it starts by showing you this DRS UA API and what packets they start at. So you can kind of start to see where the attack occurs and things like that. And look for the indicators of compromise because that's what you're really looking for in defense. You're looking for something that doesn't look right. And you're saying, that's not normal. So when you see something not normal, that could be an indicator of compromise, meaning that's where something happened. And that's where you can start to do your investigation. So that's why I'm not going to cover too much about it. I'm just walking you through the thought process. And you're looking for that indicator of compromise and follow that path of what is happening. and start to understand how that attack works, okay? So that one you guys are doing on your own. There's no answers you need, no questions. I just want you guys to get the practice, the hands-on for it, okay? So now check out the provided links and keep learning. So that's it, guys. We did it. We completed the Wireshark box. What a freaking time to be alive. We killed it. We nailed it. So thank you, guys. I really appreciate it. This was a longer video, but you guys stuck through it, and I appreciate everything you guys do, all the support. Love you guys. Thank you so much, and have a great day.